In this one, let's take a look at understanding kind of the motivation for the difference quotient. So let's take a look at this example here. First, let's review some basic slope facts because the difference quotient turns out to be basically like a fancy form of finding the slope. So, imagine this picture. This is the x-axis, this is here the y-axis, and then imagine I have a piece of curve, and let's label a couple of points. So this is a graph, and then I have a couple points on it, and imagine the coordinates of this point are the following here, okay? x1, y1, like that. Let me put a comma in here, a small comma. So this is x1, like that, comma, y1. Then the coordinates of this one, for example, could be the following here. x2 and then y2. Now remember what that means. That means the x-coordinate x1 comes from here, the x-coordinate x2 comes from about here, the y-coordinate y1 comes from here, and then the y2 comes from about here. That's that y-coordinate. Here, if you were to find the slope of the line that joins this segment right here, that line, that slope, you would apply the basic slope formula for 2 points. You would say that I would do it this way. I would say y2 minus y1. Remember, y2 minus y1 just represents the vertical change in the value of the function. So in other words, look along the y-axis. This is y2 up here, y1 down below. This is the vertical change, the space between my fingers, essentially. And then, let me move the label here. That right there, that would be x2 minus x1, like that. And that would be the horizontal change in the value of the function. Remember, this point here would be called x1, y1. So you would then do this. To find the slope of this line right here that I'm tracing, the slope of that line, you would do the following. You would basically write slope equals y2 minus y1 divided by x2 minus x1. That's just slope. Now, we're going to transition and essentially do the same thing. The only difference is use function notation instead of using labels like x and y for the coordinates. So take a look at the difference. There isn't too much difference, just the symbols are pretty much different. That's about it. So imagine again, I'm going to draw my axes here. X-axis, up here say y-axis. I choose 2 points. I draw a curve, say like this, through the points. And this time, this is going to be called x. So that's a value from the horizontal axis, x right here. Then, this point right here, I'm going to call x plus h. So what this is telling you as an example is the following. Like if x has the value 1 and h has the value 1, that would be 2 over here. If x, for example, had like the value 2 and h had the value 1, then up here you would have x plus h, which is 2 plus 1, or in other words 3. That would be the value of the x right there, you see? Like if x had the value 4 and h had the value, say, 0.5, then this here would be 4.5. So in general, what we do is we write it, as a symbolic expression. This is x and this is x plus h. Therefore, if x goes in, and this is our function f, okay, that's our f of x essentially, f of x. I'm assuming you already know that since you're studying, this concept. Since this is x, then the coordinates of this point right there, the coordinates of that point would be x, f of x. So x comes out of this horizontal axis, it goes into the function, and f of x comes out. F of x is this right here, okay? It's just a y-coordinate at that point. It's just a fancy form of the y-coordinate. Back over here, we had y1. Here we have relabeled it f of x. Over here, the next point, the next x-coordinate is called x plus h, right here. So that's the x plus h. I'm sorry, I keep putting the comma there. X plus h, that's the x-coordinate. And then when you plug that into the function, what comes out is f of x plus h. So again, x plus h is just the value of the x-coordinate. You stick that into the function by putting x plus h within the parentheses, and what comes out is f of x plus h. So in other words, f of x plus h, you would mark over here. This is right here. This is f of x plus h. It's just a fancy way of writing the y-coordinate, or value of y, a value from the y-axis. This is logically playing the role of the y2 that you see on that axis. You see? I hope you're getting that. So once you understand that, then to find the difference quotient, you're going to form a similar quantity. Back here we did y2 minus y1 over x2 minus x1. So here I'm going to do the same thing. I'm going to draw a slope triangle, connect the points with a straight line, and now it's focused on this. What's the change? Vertically, right here. So you look over to here. You see this spacing between my fingers? Like this is spacing between my fingers. I move my fingers here. It's the same spacing. I hope you can see that. That spacing is equal to the following. F of x plus h minus f of x. So this space right here, f of x plus h minus f of x. That's the difference part of the phrase difference quotient, because difference indicates you're subtracting. Then back here, we had x2 minus x1 in the bottom, this space right here, where my fingers are. So what's the logical equivalent here? Think about this. You would do x plus h, which is the value of the x at this point right here. That's x plus h. And you subtract from it the original, which is x. This one right here, subtract that. You want the spacing between them. So when I subtract, it looks like this. Let's simplify this. This is x plus h minus x. This and that other x cancel away. So all that remains therefore is h. This h tells you the size of the spacing right here. Okay, this from here to here is h. Whatever h happens to be. Maybe it's 1, maybe it's 0.5, maybe it's 0.4, or whatever. It's just a number. So that's h, the spacing from here to here. I'm going to erase this calculation, and I'm going to put a brace here to indicate this. Okay, that's h, this dimension. So we have now the ability to form the difference quotient. Here we did y2 minus y1 over x2 minus x1. We interpreted that as slope. Here the same logic applies. You form the difference quotient by writing the vertical change over the horizontal change. So it becomes f of x plus h minus f of x divided this time by h. And this quantity is the difference quotient. All right, and that's it for this one. I hope this has been truly helpful to you and that you've, really grown here. Thank you so much for watching. I'll see you in another video, and please leave a like.